Hello guys, welcome to the sixth video of module 6. Over here, first of all, you're going to look into how to implement the pipeline that we had created in our previous video on the training data. Then once the pipeline is trained, how we can use this trained pipeline on the testing data and then also understand some results based on that. So all of these things are covered in this video. So let's get started. Now, before we go ahead and start the training process of the logistic regression, I would like to go ahead and show you how the documentation of this particular algorithm looks like under the sklearn library. And then I'm also going to change two of its default parameters so that you understand that how we can use this documentation and then change some of its input arguments the way we want. So for this, I'll open a new tab and search for the documentation of sklearn logistic regression. And over here, I can just go to the first link and I'll cross check that this is from the sklearn library, that is the scikit-learn. And if you remember, in this particular code cell, we had imported the logistic regression from the sklearn.linear model. And as you can see over here, it matches this particular description. So it means that we are looking into the perfect thing. All right. Now, this is the whole documentation. If you would like, you can just go ahead and read this whole documentation and understand how exactly this sklearn guys are implementing the logistic regression. And if you would like to look into the coding part, you can go to its GitHub also, sklearn's GitHub. Now over here, I just show it to you. There is something which is called as logistic. So logistic.py. I'll search for that. And over here, there it is, logistic.py. And this is where you can find the whole coding part that you are going to import from this particular file and do some different amazing things. Okay. So it is the whole coding that you can find. You just come to its GitHub and look forward to whatever you want to find. And typically this is what I like to do whenever I'm using a particular tool. I go to its GitHub and look forward to the way that they have done the code to understand everything in a proper way. I use its documentation to understand the first look into how to use this tool. And if I'm really interested to see how the coding is done, I always go to its GitHub and look forward to a specific thing. And yes, for sure, you can also try to explore it the way you want to do it. But now the first thing I would like to show you is with respect to this paragraph. And that is in the multi-class case, which is the problem statement that we are dealing currently, because we are having different bunch of stars, right? We are having the white dwarfs, hypergiants, supergiants, and etc. etc. So because it's a multi-class classification, this particular paragraph is super duper important for us. So in the multi-class case, the training algorithm used the one versus rest scheme if the multi-class option is set to OVR, where this OVR stands for one versus rest. And it uses the cross entropy loss if the multi-class option is set to multinomial. Now what's really happening? This one versus rest is where on the output of the linear regression, sigmoid will be implemented. Now it's going to consider sigmoid as the binary classification. So what really happens over here is that out of the 6 class that you are having in this data set, it's going to consider each and every single class as the true output and all the others as the false output. So it's going to compute 2 probabilities only. But once it's going to compute probabilities of each and every class like this, we are going to normalize it so that the sum of all the probabilities will add up to 1. So that's what happens with respect to the one versus rest scheme. And the other one is the cross entropy loss, the log loss that I talked about. And this is that particular cross entropy loss function. This is going to be used if I'm going to use this multi-class option as multinomial. And it by default implements the softmax function on the output of the linear regression output. Right? And how do I know about this? I've gone through their GitHub. And on their GitHub, you can find all of this information. All right. Now, after this, I want to show you some of the input parameters that you can change. You can go through all of these parameters. The one that I'm really interested into is the solver one. So the solver is nothing but the algorithm to use in the optimization problem. So these are in simple terms, the bunch of solvers that we are offered with while using the logistic regression of the sklearn. And now you can see that there are also the variants of the gradient descent over here. But the one that I'm going to use over here would be with respect to this Newton conjugate gradient. For sure, if you would like, you can go through all of its documentation available online and read about it, and then choose the one with respect to the one that is suiting you the best. But for this particular video purpose, I'll be using Newton CG. So now that is with respect to the solver. Now the next thing I would like to change is this multi-class option. So with respect to this, you are having this three different options. By default, it's auto. So it means that with respect to the different input arguments, it's going to choose either OVR and the multinomial. You can read about that whole description over here if you'd like. But the one that I'm going to use over here will be the multinomial. The reason behind this is because I want to use that cross entropy loss, that is the log loss, along with that softmax activation function on the outputs of that linear regression that we'll be getting. So over here, what I'll be doing is I'll be using this solver is equal to Newton CG. And after that, I'll also pass this input argument of multi-class, which by default uses the multinomial if we choose the solver as Newton CG over here. But yeah, this is the final pipeline that I'm going to use. And I'll be using it for the training part as well as the prediction part. So let's do that now. I'm going to train this pipeline. So I guess I just change this name, pipeline. Right, I'll just rerun this. And I'll come over here and mention that I want to fit this on the X train and Y train. And if I run this, it's simply going to do that training process. And not only the training process, it's going to go through all the steps of the pipeline. That is, it's going to implement that standard scaler, where it's going to go through that mean of this, all the columns in the X train, also the standard deviation, and then implement the transformation. After that scaling process is done, it's going to implement this logistic regression that we have created over here with all of these inputs. Now, after the training is done, I can simply go ahead and make the predictions. And over here, what I'm going to do is I'm going to use the pipeline again. Now that's the power of pipeline, guys. I just need to use pipeline.predict, and I'll just pass the X test data. Now, because I'm using the whole pipeline, it's going to go through again this standard scaler. And now this time it automatically knows that this is the predict. So it means there is some kind of test data. So it won't again calculate the mean and the standard deviation from this data. Rather, it's going to use internally the mean and the standard deviation of this training data itself. That's the power. Without you have to explicitly code for it, everything is organized for you. And now these are the outputs that we have got for the prediction part. Just note that all of these outputs are stored in the format of an array. And I'll just save it in a variable, let's say called as preds. Pred stands for prediction. And now what I'm going to do is I'm also going to create an array for the Y test. If I look for the Y test data over here, this Y test is not in the format of an array, but I can convert it by using dot values on top of that. And now you will see that this is the array of the actual outputs. Okay, this was the predicted outputs and these are the actual outputs. Okay, this is something that your model has predict, and this is something that you already know in the data set. Now I can just print this result, both the results, the prediction and the actual. Let me just call it as actual. And after this, and after this, I'm just going to create one more line and say that I want to print with the F string. This is the actual output, and pass this actual over here. And actually I'll do this thing, I'll print this in the next line over here. And just like this, I'll copy this and do this for the prediction one. This is the prediction or predicted output. And over here, I'll be passing the preds. And I'll also like to have a space between the previous line and the starting of the second line. If I run this code, and this is the output that you can see. The actual was white dwarf in the first input of X test, and the predicted is also the white dwarf. Like that, over here it is brown dwarf in the actual set, and in the predicted it is brown dwarf. So you can see that it's correct. But the third one, actual was the main sequence, but your data, or I should say your model, is predicting it as red dwarf. So that's an incorrect predictions. So there might be some of the incorrect predictions. So let's find how many incorrect predictions are there in the data. So for this, what I'll do is I'll just basically use a way of NumPy through which I can check it, that np.where where does the actual values does not equal to predicted output. So I'll just print this. So it's going to give me this locations of the index, that on the second index and the 25th index, only two out of the total. This is where the model is not predicting well. So the zero, this is the 0th index, this is the second first index, this is the second index. As you know that second index is not predicting well, so it's correct. Just like this, on the 25th index, there will be one problem over here. So I don't really want to find it. Rather than what I'll do is I'll print the actual and the predicted label for this incorrect index. I'll just save it as the incorrect index. Okay, I'll save it as incorrect index or indexes, whatever you want to call it. Okay, I'll just change this to indexes and have an extra line. And I'll use for the incorrect or for index in the incorrect indexes. What I want to do, I want to print what is the value of the actual on that index, also the predicted on that index. So for this I'll print, I guess there's some kind of a spelling mistake over here. It's for index in incorrect indexes, and yes, everything is fine. So in this print, what I'm going to do is I'm going to say, using the f string, the actual output was actual and that index, right? But I need to pass this into this curly brackets, don't forget that. And I'll just close this one. And along with that, I'll also have one more statement, that is the predicted output by the model is spreads with that index. So let me just go ahead and run this. So you can see that the actual output was main sequence and the main sequence in both the categories. And I guess there is some problem. This is not something I want. Okay. So what is this incorrect indexes? Let me check. Incorrect indexes. Right. Run this. It's having the data like this. Okay. So if I use of 0, it's going to give me 2 and 25 both. So out of this, I want the 0th one for the 2, and the index one is going to give me 25. So over here, I'll just need to do one change. That is, I'll add a 0 over here and I'll run this. And yes, this is something I wanted. And over here, I'll just print one extra line so that it's looking good. So the actual output was main sequence and the predicted output by the model is red dwarf. And in other case, the actual output was main sequence and the predicted output by the model is the hypergiant. If I want, I can also give this kind of indexes over here. That is, I'll use enumerate and close this over here and say that this is the I. Oops, yeah, this is the I and this is the index. And I'll just have it over here like this. Whatever is that I value, I'll just do +1 to that so that it's starting from 1, not 0. And I'll just have that one. Copy that part and paste it over here. And then run it again. So this looks good, right? That the actual output for the first case was this, and for the second case, this is the output. So I guess yes, I am done over here with respect to getting an idea that in both the cases, it's not predicting well for the main sequence. Now the reason behind this would be, typically, if I show you this HR diagram, you can see that over here in the main sequence, the bottom part over here is actually belonging to the red dwarf and the brown dwarf. So it might have some of the confusion with respect to that. As well as over here, we also have the hypergiant category somewhere over here. So this is one of the misclassification that we are having in the data. But yes, this is how the model is performing based on very minimal amount of changes that we have done. And yes, this is really good actually, right? This is really good. Now, what I really want to do on top of this is to check the accuracy score, that out of the total values I'm having in the predicted output, how many of them are correct? What is the accuracy of it? So for this, you can make your own calculations if you want, but I'll be using the accuracy score from the sklearn. So I'll use from sklearn.matrix import accuracy score, and I'll be printing what is this accuracy score, and now what is the input it takes. Let me check it. Accuracy score is not defined. Okay, it's because I'm using, okay, it's because of the incorrect spelling. And yes, now this is going to work. Let's just wait for a few seconds. So these are the input parameters. It takes the actual values, comma, predicted values. So I'm going to give actual, comma, predicts. Now if I run this, okay, there is an error. Okay, there is nothing like actual. Okay, you can say I'm very bad with spelling, so no problem. Okay, I just change the spelling and this is the output I'm getting. I'm going to get 96% accuracy over here. And yeah, this is something that we have achieved. Out of total, how many? Let me check the total length that I'm having in the actual. So out of 48, because 2 went incorrect, I'm having 46 which were correct out of 48. And if I look into this, you can see that it's 96% accurate. So this is what has happened eventually over here. And yes, this is the output that we have got. I'll also delete this part because this was just done for the debugging purposes. So I'll just cross that up. And yeah, this is the accuracy that we have finally end up with after training our logistic regression and predicting it on the test dataset. Alright guys, that was about this whole video over here. And you understood that how you can implement the pipeline that we had created in our previous video on this training data. Then use this train pipeline on the testing data and then finally understand some results based on that. Now in the next video, we are going to go ahead and download this pipeline so that we can use it in order to develop our API and then also test it just to make sure that everything is working fine.